Hey, what's up, guys? My name is Matt Zimmerman. I'm the CEO at Beast Code, and today I'm going to talk about how our organization can help you with digital engineering. I'm going to start by talking about the connected environment. So typically you have a PLM where you're storing all of your 3D models, your documents, and your metadata in a structured format, something like Siemens Teamcenter. And we have a process that will integrate with Teamcenter, whether it's with a workflow or using a third-party app like eCube. That can pull out all the JT files, and then we have libraries like JT Open Toolkit or Aspose 3D that can process that information, allows us to extract all the 3D models and metadata out, and then get it into BScore, where you have a lightweight representation of what's in the PLM. Then we can integrate with other products like Cameo, that's used for model-based systems engineering. It's a SysML product. And similar to Teamcenter, we can connect directly into something like Teamwork Cloud, where you can pull in those models directly. Or we have a manual process where you can export the HTML version of the SysML models and then integrate them into BScore, which I think is cool because you're going to have the interconnected environment where you're going to want that real-time data, but you're always going to have vendors or suppliers that are providing these things separately. So having the option to be able to integrate them together. Why this is cool, why you would use BScore, is to bring these data sets together. So you can bring in Cameo models into PLM, but those are all engineering tools. So for the general user that just needs to access information, BScore is perfect for them. Being able to render very quickly a lightweight representation of the 3D models, being able to access all the parts data. We'll talk about tech manuals and documentation a little bit, but then being able to put it in context of SysML. Something like this is very complicated. There's a lot of boxes, a lot of lines, a lot of functionality that's behind it. You put this in front of a decision maker and you're trying to go over like a design change. It's really hard to just grasp quickly. So being able to use BScore to link back to say this shut-off valve here is actually this valve in the 3D model provides the context to be able to make those decisions. Also, being able to, there's a lot of use cases that you can't do in a lightweight model. So being able to click on a part in here and being able to jump back into Teamcenter or NX to be able to view those, or likewise being able to go back into Cameo from the SysML model to be able to see the context of all the models that have been built. Jumping into flexibility. Okay, so those are just two products, Siemens Teamcenter and Cameo, that are widely used, but there's others. And it's likely that at your organization you have multiple PLMs or multiple data repositories set up. With BScore, you have hashtag flexibility to where you can integrate with Siemens Teamcenter and you could integrate with PTC's Windchill at the same time. They could be similar data sets or they could be completely different. But again, being able to bring them together to see the full context of what it is that you're building or maintaining. There's also, depending on the size of your organization, you may have other departments, other companies that have these types of digital engineering environments that you might want to bring data into. And then when we're talking about the government, they have IL6 or classified type environments where you want to be able to move information into, but not necessarily out of. And so you end up with this environment of multiple PLMs, multiple MBSE type tools, multiple data repositories that aren't typically connected together that are now brought into one. That's the connected environment. Like I mentioned with SysML and wanting to have the ability to manually update because you have other vendors outside of your organization that have data sources. The same is true when you get into like 3D models. A lot of times we're working with bigger platforms, say building like a ship or an aircraft, where one vendor may build 90% of whatever that platform is, but the other 10% are parts and pieces that come from third parties. And they typically do have 3D representations, but they're all going to be built in different CAD products. Some that we deal with are CATIA, Ship Constructor, Rhino 3D, and there are others. We have a process where you can send those files to Beast Code or use some of our tools, and we can build custom tools as well to be able to process that information. bunch of different libraries that we use: ASIM, JT Open Toolkit, ASPOS 3D, Open Cascade, and others that we use to be able to integrate with those technologies. A lot of times as well, we have to build custom scripts. There's other products that are out there that when you export the information and try to bring them into these libraries, you lose a lot of the metadata. And so we've built in the past a lot of scripts to be able to process it and be able to maintain all that information. So then you can convert it to a lightweight format. We can apply all our optimizations and you still get all the metadata. And when you get into documentation, typically you use like Autodesk, AutoCAD type products. Those are drawing files or DWGs. Those get converted into PDFs. Hopefully searchable. If not, you can use OCR technologies, and we have those at Beast Code to be able to make them searchable. But once we have that, those documents go into B-Score, where you can view them, and we take all the searchable text, and if there's any text that matches something in our metadata database, we create these purple hyperlinks so you can click on any of these and it'll jump you back into the 3D model. DWGs aren't the only thing we encounter. There's obviously going to be a lot of Word documents, PowerPoints. Those can all be exported to PDF formats. You can do the same thing with Excel, but it's not as elegant. It's very hard to get Excel pages to line up with PDF type pages. But a lot of organizations are using things like Microsoft 365 that are cloud-based. And so instead of actually opening up those documents in B-Score, we could have the hyperlinks that open up in another tab. So actually being able to open up Excel and having all the functionality there. Very similar to the idea of I want to open a 3D model back in the PLM, or I want to be able to access one of these boxes from SysML in my MBSE product. And so that provides the capability to have this interconnected environment, as well as be able to work with a variety of different vendors to bring in all this information. And it gives you this one-stop shop digital engineering environment where you can see all of your information. Cool thing with this is once you've set this up, there's a lot of freebies that you get downstream. So a lot of use cases that we work with are maintenance based. We have a product called B-Score for logistics, and so if you are a maintainer, whether it was in a facility, a flight line, or on board like a weapon system like a ship, being able to, within your context, be able to bring up the 3D model, be able to access the parts data that you need on the day-to-day, be able to search across any of the information we have, as well as be able to open up any of the technical documents. It's like a lightweight version of that digital engineering environment that can be deployed anywhere you need it, including disconnected environments. We also have a learning platform that once you have all this information, again, you can, through a drag and drop interface, say, I want to be able to render a 3D system and fly to each component and present information about what are the operating characteristics of it, whether that's text or HTML, could be an embedded video, an embedded document, but being able to create these interactive learning experiences that you could have as part of courseware, like people that are actually going to a physical school, or it could be more disconnected where people are logging in to access this information. Or it could be like just-in-time training. I have to go do maintenance on a pump today, and here is a course using the 3D model that walks you through that. We also have B-Score for operations that links into like the real-life sensors to be able to pull in, I got a fire alarm that's going off and I want to see exactly where that fire alarm is, or I have a pump that has some type of an alarm going off or some type of issue with it that we want to present. You can integrate predictive technologies, whether it's predictive maintenance or artificial intelligence in between. We have a lot of use cases working with organizations where the sensor readings go into those types of platforms, and then they're presenting the issues in B-Score, and then that provides the context back in 3D of where the actual issue is located. The user can access all the information they need to actually address it, like the parts numbers, or bringing up the technical documents that they need to actually do the fixes. Or back into the case of learning, being able to have the 3D walkthrough that shows you how to actually address the problem. And a lot of that you kind of get downstream. Once you have all of your information organized in this digital engineering environment, that's the data you need to be able to do these use cases for logistics, learning, and operations. And then there's some other like downstream ideas of what people are using B-Score for today. That same learning platform, that drag and drop interface, we talked about it for teaching people things, but think about it from the context of a design review. Instead of using a PowerPoint to show a 3D model or a new concept, being able to use the real life interactive platform to get that point across. Or being able to integrate AI, something as simple as like a large language model. B-Score has all the information from all your applications behind it that we can feed into an LLM to be able to answer the questions that you might ask it. And then beyond like the 3D CAD models, integrating reality capture. So being able to compare the as built, as designed representation with what was really built, and being able to overlay the two on top of each other to see how close they are. Or based on the life cycle of your application, as it's being maintained and altered, being able to scan in what are those alterations and changes and putting those back into a digital engineering environment so you can view them without having to go to the real life platform and potentially skip updating all your CAD models as well. And there's a myriad of other use cases, including B-Score has what we call the plugin architecture. So any of the ideas or customizations that you might come up with, you can easily build yourself. Anyways, that is our concept for digital engineering. If you have any questions, feel free to shoot us a message and we'll jump in, learn more about what it is that you want to do, and be able to provide you with solutions. See you later.